Okay, so what we're going to do is just going to look at, this is the main extra thing that we're focusing on, finding any points of inflection. We're going to find the state point, determine their nature, find the points of inflection. The points of inflection are in between your stat points, and then sketch the curve. Okay, so part 1, find any of the stat points, so you differentiate. Take the 3 out, so you get minus 2x minus 3. Factorise. Make y dash equal to 0. The 3 will just cancel out. So x equals 3 and minus 1. You then need to find your y value, so you put the 3 back in to the original curve. And you get minus 20. So that's putting you into this original one here. So go 3 cubed minus 3 times 3 squared minus 9 times 3 plus 7. Okay, and then you get the x equals minus 1, and you put that into the original curve, and you end up with 12. So you have the point 3 minus 20, the 2 points, and minus 1. Okay, the next thing is to determine the nature. So to determine the nature, there are 2 different ways to do it. You could use y dash, you can use y double dash. So I'm just going to run through both of those ways. Okay, so we have our 2 points. So if we used y dash, then we could draw up a big long table of value and put x, y dash. So this involves quite a bit of subbing. And, you know, it's good, but if y double dash is really quick and easy to find, sometimes that is actually a better method. So I'm going to do y double dash here just to show you that it is like sometimes another way of doing it that is a little bit quicker. So I'm just putting points in between these, and I know at those points they're 0. So that's 4. So if I sub in x equals minus 2, now I'm putting into y dash, so always put the factored form. Because if you do that, it's much easier to see the sign. And you're only interested in the sign. You don't actually have to calculate the whole thing. See, that's a negative and a negative, so it's a positive. And then when you put in 0, it becomes really easy then to see what this is as well. See, that's a negative times a positive. So that's a negative, and then you put in x equals 4. So you go 4 minus 3, 4 plus 1, that's a positive and a positive. Okay, so that would be a positive. So therefore, when you're looking at the type of stationary points, that would be positive gradient, so it's going up, 0, negative gradient, 0, and positive gradient. So you can see at the first point there, that is a maximum, the second point, that is a minimum. So the first point is a maximum, and that's the minus 112, and the second point, 3 minus 20, is a minimum. So if you look at now doing this with y double dash, so here's y dash, so y dash is 3x squared minus 6x minus 9. Y double dash is 6x minus 6 when you differentiate. If you put in x is minus 1, y double dash is 6 times minus 1 minus 6, minus 12, which is negative, so it's a maximum. And if you put in 3, y double dash is 6 times 3 minus 6, 18 minus 6, which is 12, so that's greater than 0. So that is a minimum. So at 3, it's a minimum, and at minus 112, it is a maximum. So at 3 minus 20, that's a minimum, and minus 112, it's a maximum. So when we are sketching this, if we go to minus 1, 12, so I'm just going to go up by 10, that's minus 10, minus 20. Notice I just need a proper scale, like the same scale on the x-axis, the same scale on the x-axis, and the same scale on the y-axis. You've got minus 2, minus 3, so x, there's y, So if I go to -1, I'm just at 12, and if I go to 3, I'm at -20. You also need the y-intercept, so if you put in x equals 0 into this, then we've got 9x plus 7, then you'll end up with 7. That's the constant at the end. Y is 7. So it's also important that you mark in your y-intercept there as 7. And I like you to put, just because this makes you not make mistakes in tests, if you just plot the point onto the diagram. Now we're not going to have to find the x-intercepts because we haven't been asked, and to actually factorise this polynomial would take us way too long, and it's out of the syllabus of 2 unit. Okay, so let's look at another example, and this one is going to be okay, sorry, we now need to find the points of any points of inflection. Okay, so with the points of inflection, the points of inflection occur when y double dash equals 0. So you make 6x minus 6 equals 0. So therefore 6x equals 6 and x will equal 1. You then need to find the y value by putting it into the original curve. So you get, that would be 8 minus 12, you end up with minus 4. Now, it's not good enough just to find the point of inflection. You have to check y double dash changes sign. Now, this is just the point of inflection that becomes in between our two start points. If you go back to our curve here, when you go to 1 minus 4, that there is the point at which the curve goes from concave down to concave up. So it's important that we always check that it is actually changing concavity. So you need to actually put that into the 6x minus 6. So that's going to be 1. Let's go 2 and 0. And put 0. So if we put in 0 in there, 6 times 0 minus 6 is minus 6, so it's negative. And you put 2 in there, that's going to be 6, so that's positive. So therefore y double dash changes sign, therefore changes concavity. So it is important that every time you do an inflection point, you also do a box for y double dash to check that it changes concavity.